Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Kropki Whisper Loop by Yitrio, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that every row, every column, and every designated 9-cell region, which is a box in this case, is filled with the digits 1 through 9 once each. We need to draw a 1-cell wide loop of orthogonally connected cells. The loop may not touch itself, not even diagonally. So that means, another way of putting that is basically, we need to draw a loop where basically every cell in the loop shares an edge with exactly 2 other cells on the loop. And on top of that, if it shares a corner with another cell on a loop, they must be either neighbors or they must share a neighbor, right? So for example, this cell shares an edge with 2 cells on the loop. It shares corners with this cell, this cell, this cell, and this cell. These 2 are neighbors, and these 2 share a neighbor. So this is all valid for this loop. What would not be valid for this loop, though, is say we went something like this. This is not a valid orthogonally connected loop. And orthogonally connected just means that usually means that orthogonally connected cells are essentially cells that share an edge. But this is not valid because these 2 cells, even though they share an edge with exactly 2 cells on the loop, they share a corner with each other, and they're not neighbors, and they don't share a neighbor. So this is why this is not valid here. This also would not be valid because even though these now, well, actually, they don't even share a neighbor still. This cell shares an edge with 3 cells on the loop, which is not allowed, and therefore it's considered touching itself here. And this would be considered touching itself on the corner. So those are examples of orthogonally connected loops which may or may not be valid. The loop acts as a German whisper line. That is, adjacent digits on the loop must have a difference of at least 5. Or as I like to call them, whisper 5 lines. So for example, if this were the loop and this were 3, these digits would have to be 8 or 9, because those are the only digits which are 5 or more away from 3. We also have digits separated by a white dot are consecutive, and digits separated by a black dot have a ratio of 2 to 1, and not all possible dots are necessarily given. And these are called Kropki dots, which is why this is the Kropki whisper loop. The whisper is the German whisper line or the whisper 5 line, and the Kropki dots are the Kropki part. So, for example, if this were a 6, this would have to be a 5 or a 7, because there's a white dot between them, which signifies they're consecutive. And if, for example, this was a 2, this would have to be a 1 or 4, because there must have a 1 to 2 ratio between them, because there's a black dot between those. And for each given dot, at least one of the digits touching the dot must be on the loop. So of these sets, basically each of these Kropki pairs, one of them at least must be on the loop. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so at least one of these is on the loop. At least one of these is on the loop. Okay, and they act as a German whisper line. Okay, so For white dots, they cannot be consecutive. Because, actually, for black dots, they can't be consecutive either. Right? Because if you have black dots, there's difference of at most 4 between them, right? Because the biggest difference between digits with a 1 to 2 ratio is 4 and 8, right? 5 and 10 is 5, but 10 is not a digit. So there's no way that it can be the loop can be part of both of the cells of a black dot and both of the cells of a white dot, because the difference between excuse me, cells with a white dot is 1. So obviously they both can't be on the whisper 5 line or the whisper 5 loop. And the same with the 1 to 2 ratio. The difference is at most 4 between two digits with a 1 to 2 ratio. So either this is part of the loop or this is part of the loop. It cannot be both. And if we try to have both this as part of the loop, it cannot be part of this. So it has to do something like going here and then go out, but then it would be considered touching itself. So these two cannot be part of the loop. Because again, if it tries to enter in this way, it has to exit out this way, but then it's touching itself. So those aren't part of the loop. This must be part of the loop, and this must be part of the loop, which means it enters in here and exits out this way. It enters in this way and exits out this way. So this is not part of the loop because it would consider touching itself. It has to exit out this way. It cannot go this way because it would be considered touching itself on the corner. So that's not allowed. That means it must go this way. On a German whisper line or a whisper 5 line, you'll always alternate between low digits and high digits. Okay, this cannot be on the loop because it would consider touching itself, so it must go that way. It either goes this way or it enters this way. We don't know. So it could be either of these. We're not sure which. On a German whisper loop, again, you'll alternate between low digits and high digits. So the problem here is, okay, so if this goes this way, that's not information that we can go. These digits on a black next to a black Kropki dot are either 1, 2, 2, 4, 3, 6, or 4, 8. So those are the possibilities. So it either goes this way out, or it goes this way. Okay, so this is always on the loop. It goes out this way, or it goes this way. Okay, so this is always on the loop also. So it can go either that way or this way to be on the loop. Or it could even go, it can't go this way, because if it goes this way, it would be considered touching itself. So this is not on the loop. Well, would it? It could technically go this way. Yeah, it could do something weird like that. That's possible. So we won't rule that out. No, actually, it cannot. One of these two is definitely on the loop. And if it goes this way, it would be considered touching itself there. So this is not on the loop. Yeah. So if it goes this way, it must enter here, one of these. So it must go either here or here. If it goes here, well, it doesn't have to go this way. It could actually go this way, and this one could go something like that. Okay, let's look at this one. These digits have to be they are next to two unique digits on the Whisper 5 line. Right? This is next to those two, 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 etc., etc. This is next to those two. So these digits have to be 1, 2, 3, 7, 8, 9, because the only digits 4 and 6 can only be next to one unique digit on a Whisper 5 line. 4 can be next to 9, and 6 can be next to 1. And 5 can never be on a Whisper 5 line. So, because 5 is in... If you subtract 5 or more from 5, you get 0 or less, which is not a normal Sudoku digit. And if you add 5 or more to 5, you get 10 or more, which is not a digit. So this has to be 1, 2, 3, 7, 8, 9. That means this digit has to be 1 through 4, 6 through 9 as possibilities. Where is the 5 then in row 1? Row 1 cannot be here. The 5 cannot be here because they're next to two unique... They're on a Whisper line, a Whisper 5 line. These are on a Whisper 5 line. This is in a 1 to 2 ratio. And 5 can never be in a 1 to 2 ratio with another digit. 5, if you have it, you get 2.5, which is not a digit. 5, if you double it, you get 10, which is not a digit. And this digit can't be 5 because it's next to a 1, 2, 3, 7, 8, 9. And 5 can only be consecutive with 4 or 6. So the 5 in this row has to be here, which means this is not on the Whisper 5 line, which means this must be. So this is not, so this has to be on the Whisper 5 line here. This digit is next to two unique digits on the Whisper 5 line. This digit is next to two unique digits on the Whisper 5 line. Therefore, this must be 1, 2, 3, 7, 8, or 9. So, that means, where are the 4 and the 6? Excuse me. In row 1. One of them has to be here. Because if we tried to have both of them here, that would be a 1 to 2 ratio between 4 and 6, which is not possible. So one of them has to be here, which means it's next to 3 or 7. The other one must be one of these two digits. Jeez. So guaranteed 4 and 6 in this box here, in box 2, in one of these 3 cells. Cannot be 1 here. So it could be 3, 6 as a pair. So if this were 3, 6, the problem is that would force this to be 4 and 7. And this is not possible because that's not consecutive. 4 and 7 are consecutive with each other. So this cannot be 3 and 6. Therefore, it's 4 here with 2 or 8. That eliminates 4 here. So this is 6, which makes that a 7. Which eliminates 7 in the rest of the column and box. So this is a high digit, and on Whisper 5 lines, or otherwise known as German Whisper lines, you'll always alternate between high digits and low digits, because what digits are 5 or more away from 6, 7, 8, 9? 6 can be next to 1, 7 can be next to 1 or 2, 8 can be next to 1, 2, or 3, 9 can be next to 1 through 4, which are all low digits. 1 digit can be next to a low digit, which is 1 through 4. 4 can be next to 9, 3 can be next to 8 or 9, 2 can be next to 7 through 9, and 1 can be next to 6 through 9, which are all high digits. So this is a high digit. I guess we'll make the blues medium gray instead. And these must be low. This must be high. And we have low, high, and this is low. So on this, if you know you're on a loop, you'll always be able to know what set these... We know these are on the loop. We know what set they have to be on, because you just take the shortest possible path, and that's the only possibility you could have to have those specific sets. So I'm not sure if I'm explaining it correctly. But basically, since this is high and this is low, take the shortest distance to there. That would be high, low, and high. So we know that specifically, right? And if you try to loop any other way to this spot, you have low, high, low, high, low, high again. Low, high, low, high, low, high, low, high again. It's always going to be the same. And this is because you're alternating between two sets on this loop, and you can only move orthogonally. You cannot move diagonally, which changes how you could potentially set these on the loop. But therefore, we know this is always high, this is always low, this is always high, and this is always low. This is high. We have 3 highs already then in row 1. Sorry, 4 highs, including the 6. So therefore, the rest of the digits cannot be high, so this cannot be high at all. This becomes a 2-4 pair, which eliminates 2 and 4 in the rest of the row. And this is high. So this is 8, 9. This is 1, 3. This is 8, 9. This is 1, 3. 7 cannot be next to 3 on a whisper 5 line. So this is 1. This is 3. That means this has to be 1 or 2. Sorry, 2 or 3 here. And this is 8 or 9 as a pair, which could be next to 1 through 4 here. This is next to a 7 on a whisper 5 line, so this must be 2, which makes this 3. So this cannot be 3 here. If the 2 tried to go this way, the only high digit left is 6. And 2 cannot be next to 6 on a whisper 5 line, so it must go this way. So that's high. This digit must be a high, which makes this a low, which makes this high, which makes this low. Not green, orange, it makes it low. So this has to be 6 or 8. The only digit that 3 can be next to on a whisper 5 line out of 6 or 8 is 8. So this is 8. That makes this 1 to 2 ratio with 4. This 8 eliminates 8 here, so it's 9. Which means this can't be 9. That's 8, which makes this 9. These 2 high digits can only be 7 or 9. Because we cannot have a 6 because of the 6 in the box, cannot have an 8 because of the 8 in the row. So this is 7 and 9. That leaves this digit as 1. Because we can't have 2, 3, and 4 there because of the 3, 4 in the box and the 2 in the row. So that's 1. This has to be, it's next to 2 unique digits. It cannot be 8 or 9, and it's a high digit, so it has to be 7, which forces this to be 2 here. That means 2 cannot be here. If we tried to go this way, the problem is the only low possible then in row 2 would be 4, and 4 cannot be next to 7 on a whisper 5 line. So this is not on the whisper 5 line. It has to go this way, at least, which means this is not on the whisper 5 line because it would be considered touching itself. This cannot be 2 or 4, so it has to be 1 or 3 here. This must also go this way, and it must be low, so it has to also be 1 or 3 here. So the remaining digits in this box are 5 and 8. 8 cannot be here because of the 8 in the row, so this is 5, that's 8. 8 could be this way, so it could connect that way, we don't know. It could technically go this way too. This 6 eliminates 3 6 as a possibility for this 1 to 2 ratio. 2 could go here. Let's see. Remaining digits in row 2. We have 4 and 6. This can't be 4 because of the 4 in the box, so it's a 6, which makes this 4. Remaining digit in rows 3, this has to be 2. Therefore, this has to be a 5, 6 pair here. This could be 4 here. We don't know. Remaining digits in... Let's do remaining digits in column 9. We have 3, 4, 6, 8, 9 left. Remaining digits in column 8. We have 1, 2, 5, 6, 7, or 9. And 2 cannot be any of these digits here. Remaining digits in column 7. 1, 3, 4, 5, 7, 8. So, what digits can be consecutive here? You cannot have 9. It's either 1, 2 here or 5, 6, 7. 5, 6, or 6, 7. If this were 1, that would mean 2 would have to be here, but that's not consecutive with anything, so this cannot be 1 here. These two digits are consecutive. It cannot be 1. 3 is consecutive only with 2 and 4, and this can't be 2 or 4, so this can't be 3. 4 can be consecutive with 5. 5 can be consecutive with 6. 6 can be consecutive with 7. 7 and 9 can be consecutive with 8, so those are all possible. Oh yeah, and you'll always alternate between lows and highs. So again, similarly to be on the set. So this would be low, high, low. So this would have to be low if it were on the loop. So it cannot be because it can't be 1 or lower. Sorry, it can't be 1 through 4. So that's not possible. So this has to be on the loop. We know for certain. It cannot come this way. So this cannot go this way because this is never on the loop. If it goes this way, it would be considered touching itself. So it cannot go that way. So it can never go this way. It has to go this way, which makes this an 8 or 9 here. It can't enter. This is not on the loop. So it must enter this way. So that must be on the loop. So it cannot be. This has to be a 3, I think. If you try to make it 4, it would be guaranteed to be between 2 unique digits on the Whisper 5 line. So this has to be 3. That eliminates 3 in the rest of the column. If this is on the loop, it's low. If this is on the loop, it's high, right? Because low, high, low. This also eliminates 3 in the rest of the box. If we try going this way, it has to connect to this cell because, again, they share a corner. So then they would have to share a neighbor or be neighbors. They're not neighbors, so they would have to share a neighbor. So it would have to go this way. But then the problem is, how does it connect to any cell here? Can't be this one then, if it goes this way. And then the problem is, it would have to connect to here, but then it would touch itself necessarily to get out. So this cannot go this way. This has to go this way. 3 is always between 8 and 9, so this becomes an 8-9 pair here. If it went this way, so it cannot go this way, so this is not on the loop. If it goes this way, the problem is this digit would have to be next to 2 unique digits on the loop, and 4 and 6 can only be next to 1 unique digit on the whisper 5 line. So it has to go this way, which means this is low. So this must be 1 or 2, which means this is 1 or 2 to be in consecutive with it. So this is not on the loop here, obviously. These can't be on the loop because to enter in, they have to enter in and they can't get back out. This has to exit out that way to be on the loop. It has to be 7 or 8. This 4-6 pair eliminates 4 and 6 in the rest of the box. This 1-2 pair eliminates 1 and 2 in the rest of the column and box. So this is 7 or 8 here. This is on the loop, so it must be 7 or 8. That 7, 8, 7, 8 pair eliminates 7 and 8 in the rest of the column. Therefore, this becomes a 3-5 pair here, which eliminates 3 and 5 in the rest of the column. So this becomes a 1-4 pair here. This 3-5 pair also eliminates 3 and 5 in the rest of the box, so this can't be 5. This could go that way, or it could go this way. You could do something funky like that. Okay, so say you could exit that way. That's possible. This is low, so it could go that way. It could do something funky like this, too. No, it can't. So if it tries going this way, it would have to exit out immediately. Because it cannot go this way, because 4 cannot be next to 7 or 8 on the Whisper 5 loop. So if it tries going here, and then entering this way, that does not work. So it must be in one of these cells. If this is not on the loop, it can only go in and out, and then it would be touching itself. So that's not allowed. So this must go this way, which means it cannot be 4. It's 1 between 7 and 8 on the whisper loop. So this must exit out this way. Since it goes out this way, so these are no longer possible to be on the loop. This cannot be, because then it would form a loop by itself, which it's not one large loop. So this is not on the loop, which means this must go that way. So that's done. These cannot be on the loop. This is low. It can't go here because that would be considered touching itself. It can't touch any of these cells because it would be considered touching itself. It can't enter in here and then exit back out, so these are not on the loop. So this has to go this way. And then either goes here and goes through, or goes this way. Even if it goes this way, it can never go back here because it would be considered touching itself. And it tried to go this way, it would be considered touching itself. So none of these could be on the loop. This is low. It's next to 7 or 8, so it's 1, 2, or 3 here. This is next to 2 unique digits, so it has to be 7, 8, or 9. Cannot be 8. It's 7 or 9. We have a 7, 8, 9 triplet in row 5, which eliminates 7, 8, and 9 in the rest of the row. This can't be 8. This can't be 7 or 9. We have 5 and 6 next to 7 or 8. This must be 6 and 7 to be consecutive. So this is 6, that's 7, which makes this 8, which makes that 9, which makes that 8. This can't be 6 or 7. This can't be 6 or 7. We have a 5, 9. This 9 eliminates 9 here, so it's 7. 7 can only be next to 1 or 2 on a Whisper 5 line. This 7 eliminates 7 here, so it's 9. Okay. If we go down here, it would have to be a 2. And this would be 4, 8. This cannot be 1 and 2 as a pair because that would eliminate all possibilities for this cell. So 1 cannot be here. We are guaranteed a 4 has to be one of these two digits. If we go here, this cannot be 4. So it would be 2. If we go here, then here, this would have to be 2 to be between 9 and 8. So I think, okay, so if we go this way, that's a 2. Because 4 cannot be between two unique digits on a Whisper 5 line. If we go this way, this has to be 7, and then this would be 2 to be, this would have to be 2, because it cannot be 1 or 3, and 4 cannot be next to two unique digits on a Whisper 5 line. And this would have to be 2. So this can, either way, this cannot be 2. This is 1, which makes this 3, which makes that 1. Okay, if we tried going this way, we could, and then enter in that way. That's possible. But then this would be considered. So this is, I don't think we can go this way. If we go this way, that's 2, and then this would be a high digit, but it cannot be, we don't have a high digit available. So this actually can't be high either. We have 6, 7, 8, 9 already accounted for in row 5. This cannot be high. Since that can't be high, it can't be on the loop. So it must go this way, which means it must go this way. Again, you can't have a high digit here. So this has to go, cannot go this way. That means it can't go this way either. So it must go this way as a low, and this must be high. This has to go this way. And it could go to something like this, or it could go, yeah. This is 2. This has to be high and is an 8, which makes this in a 1 to 2 ratio with 4. This is a low digit, so it's 2 or 3. And it's next, this has to be 7, 8, or 9, because this is only 2 or 3. The remaining digits in the row actually have to be 2, 3, and 5. This 4 eliminates 4 here, so it's 1. This cannot go this way, because if it did, the only low left would have to be 4. And it could go this way and be 4, and then this is 9. Okay, so it can't go this way, because if that's 4, then it has to be next to 9 on the Whisper 5 line, but we already have a 9 there. So it has to go this way. So this is not on the loop. This is not on the loop. This has to go this way and is low. We have 2 lows in... We already have 2 lows in column 2. So this is 2, 3, and 2, 3. 2, 3 can be next to 1, 2, 3, 4. This can't be 1 or 3. So this is 2 or 4, which must be next to a 3 here, because that's consecutive with it. So this is 3. That makes this not 3, so it's 2. 3 can only be next to 9 out of 7 or 9 on a Whisper 5 line. So this is 9. This cannot be 9 here. These can't be 2. This digit cannot be an 8. Sorry, this digit is next to an 8, so it can't be 4. It can't be 1, 3, or 4, so this must be 2. So since this is 2, this is 4, this is 1, which makes this 2. Can you go high here? Possibly. If you go high here, this would be a 7 at most, and 7 cannot be next to 3. So this wouldn't work. So this cannot be high. It has to go this way, which means it must go this way at least. This is 8, because it cannot be 9, and 3 can only be next to 8 or 9 on a Whisper 5 line. That makes this 7. This cannot go this way, because there's no more lows possible. So it has to go, it can't go anywhere any weird way that way, so it has to connect here. So this is a low. Cannot be 2 or 3. It's next to at least an 8, so this must be 1. And this has to be 7 or 9, because it's next to 2 on the Whisper 5 line. And these are not on the Whisper 5 loop. This 3 eliminates 3 here, so this is 5, which makes that 3. Okay, let's see. This 2 eliminates 2 here, so it's 4 and 2. We have a 7-9, 7-9 pair in column 4, which eliminates 7-9 in the rest of the column, so this must be a 3-5 pair and a 3-5 pair. We have a 5-6 pair in column 2, and we have a 3-5, 3-5 pair in row 9, which eliminates 3 and 5 in the rest of the row. This can't be 5, so this must be 6, which makes this 5, which makes that 6. This 6 eliminates 6 here, so it's 4 and 6. Where is the 8 in box 4? Cannot be here, so this must be 8 here. That leaves the remaining digits in box 4 as 4 and 6. And this can't be 4 because it's 4 in the column, so it's 6 and it's 4. This 9 eliminates 9 here, so it's 5 and 9. Remaining digits in column 1 are 2 and 7. This can't be 2 because of 2 in the row, so this is 7. That's 2. 7 eliminates 7 here, so it's 9, which makes this 7, which makes that 9. Remaining digits in column 3 are 5 and 9. This can't be 9 because of the 9 in the row. So this is 5, which makes that 9. We have 8 ones. We should know where the last one has to be. It has to be here. We have 9 twos. Okay, so that's done. We have how many 3s? Not enough. How many 4s? We have 8 4s. We know where the last 4 has to be. It has to be there. 5. We don't have enough 5s. Actually, we kind of do. Where is the 5 in box 8? Cannot be here. Cannot be here. Therefore, it must be one of these 2 digits. And it can't be here, so this must be 5, which makes this 3, which makes that 5. This 5 eliminates 5 here, so it's 3. So that's 5. We have 8 5s. We know where the last 5 has to be. It has to be there. 6s. Where is the 6 in box 5? It has to be here. That means it gives us 8 6s. We know where the last 6 has to be. It has to be there. 7s. The 7 in box 5 has to be there. We have 8 7s now. We know where the last 7 has to be. It has to be there. 8s. We have 8 8s. We know where the last 8 has to be. It has to be there. 9s. We should have all of them, I believe. And that leaves this digit as a 3. And that's a solution. Yeah, I don't know if I would consider this easy. I think it's in between easy and average or challenging for me, so I would probably label it as that harder one. I don't know. These ones always make... I'm always uncertain how to rate these difficulty-wise, because it feels like it's a lot of work. It's not that hard, though, logic-wise, but there's a lot of work involved. I don't know. I'm not sure which one makes the most sense to me. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.